Chapter 13 talks a lot about concentration. When we talk about concentration, we're talking about concentration of an aqueous solution. So a solution is a homogeneous mixture, meaning it only has one layer of a substance. Any substance in smaller amount is called the solute, and any substance in larger amount is called the solvent. When you combine the solute, in this case, in this picture, we have salt and we have water. So salt would be the solute and water would be the solvent. When we combine them, we have the solution. So the solute and the solvent together are the solution. Concentration tells you how much, what is the ratio of the solute, the particles in smaller amount, to the solvent. So whatever is in larger amount. If it's an aqueous solution, then your solvent is always water. So here are two very common percentages of concentration, and you find this on many medications. There's percent by volume, and that's the volume of solute, if the solute is a liquid, over the volume of solution, which is, again, the whole thing, solute and solvent, usually water for the solvent. Percent by mass is the mass of the solute in grams over the mass of the solution. Now remember that the solution is everything. Oftentimes the density of the solution is 1 or close to 1. So these two, percent volume, percent mass, will give you the same result because the volume of the solution and the mass of the solution are often the same. So 1 milliliter of the solution is often 1 gram of the solution. This is especially true with dilute solutions. So in example 1, what is the percent by volume concentration of a solution that is 75 milliliters of ethanol, and it is then diluted, meaning they're adding water, to 250 mils. So it started off with 75 mils of ethanol, which is drinking alcohol, and they added water to bring it up to a total volume of 250 mils. So what you do to figure out the percent volume, these are both liquids. Ethanol, like I said, is drinking alcohol pure. So it would be 75 milliliters over the entire thing. And since they brought it up to a total volume of 250 mils, you don't have to add on the 75 because they just brought it up to the 250 milliliter mark. But you do have to multiply percent anything by 100. So this would be a 30% solution by volume. Example 2 says what volume of acetic acid, and acetic acid is found in vinegar in very small amounts. It's a very weak acid that smells bad. So what volume of acetic acid is present in a bottle containing 350 mils of a solution, meaning acetic acid and water, and it's 5% concentration, and that's typical for vinegar. It's about 5% acetic acid. So now you are going to do a little back calculation. You know that you have 350 mils of your total solution, so that goes on the bottom. You know that you have the ratio of the two are 0.05 because you divide the 5% by 100 because you get rid of the percentage. And then what they want to know is X. What was the initial volume of the acetic acid? So when you multiply 350 by 0.05, you get X by itself, and you get your 17.5 milliliters. They had 17.5 milliliters of pure acetic acid in there. Example 3 is find the percent by mass. Now this one is really, really common. And it's sodium chloride, which is table salt, and it's dissolved in 331 grams of water. So the table salt is the solute because it's in smaller amount, 41 grams. The water is the solvent, 331 grams. And if we added them together, the 41 and the 331, we would have the solution. So that's what they've done here. They've taken the 41 gram solute, always goes on top, the solute that they're interested in. They took 331 plus 41 to get 372 grams because you always need the solution on the bottom. So you need that for the volume and for the mass percent, whichever way you're calculating it. And then again, percent anything is times 100. So when they multiply by 100, they get 11%.